24, the integral from 0 to 1, sine of square root of x over x plus x to the fourth dx. This is improper because we have a domain restriction. X cannot be 0, and one of our limits is 0, okay? So this one, let's have some intuition. Okay, when x is very small, which means as x approaches 0, essentially, sine of square root of x is approximately equal to square root of x. This is in physics, we call this the small angle approximation. That sounds familiar. And you do that for a lot of things, like when you learn about lenses and diffraction and that stuff. You use the small angle approximation. But anyway, so when x is very small, x plus x to the fourth is approximately equal to x. Okay, you can imagine, precisely because as x is approaching 0, so just imagine like x is 0.1. 0.1 versus 0.1 to the fourth power. This is 0.1 to the fourth power. It's much smaller than 0.1. Okay, that's why as x keeps getting even smaller and approaching 0, this x will dominate. This x to the fourth will be insignificant, okay? So therefore, our guy will behave very similarly to integral from 0 to 1, same limits. Instead of sine of square root of x, it will behave very similar to just square root of x by what we set up here. And the bottom will behave very similarly to just x, okay? Which if we simplify is 1 over square root of x, okay? And if you remember, this guy converges. So it's likely that our guys couldn't converge as well. And some people might stop here and use the, what do you call it? The asymptotic comparison test or whatever. I'm not doing that here. I feel like I have to defend myself in every video now. But I'm not doing that here because most people don't learn it. So we're going to do a direct comparison test. All right? So we're going to use this intuition to help us out though. Okay? We're going to set up some inequalities and we might take a few steps to try to kind of establish our arguments per se. Okay. So on this specific interval from 0 to 1, that's our limits of integration. Okay. Sine of square root of x is less than or equal to square root of x. Okay. This, hopefully, we can understand. Even just sine of x, pretend the square root's not there, okay? Sine of x is less than or equal to x if you just imagine the graphs of sine of x and x. X actually grows faster, especially in this interval from 0 to 1. We're specifically only talking about this interval, okay? So therefore, square root of x also would grow faster than sine of square root of x on this interval, okay? So now we just divide both sides by x plus x to the fourth. Okay. And this side over here, okay, we can write another inequality is less than or equal to square root of x over x. This one's hopefully more easy to understand. We've done this many times if you're following along sequentially. We're dividing by something bigger, even though x from 0 to 1, we're still dividing by something bigger, okay? Therefore, this guy's going to be smaller, okay? And this, we can simplify to 1 over square root of x. This is what we were saying in the beginning. This is the intuition we had. So we could use this as our direct comparison, actually, now that we showed our work. Okay. So once again, we just need to know this, first of all. That's the prerequisite. Even just sine of x is less than or equal to x. So sine of square root of x would be less than or equal to square root of x as well. And then we divided both sides by x plus x to the fourth, and then we did set up one more equality, okay? And that I just showed my work, that integral from 0 to 1 over square root x dx converges right there. So therefore, since our guy is even smaller than this guy over here, our guy is going to converge as well, since the bigger guy converged.